Hi, I'm Suresh Goyal from Nokia, and I'm here with my great friend and colleague, Steve.
Hi, I'm Steve Dinkins from Intel, and I'm the Director of Wireless Core Infrastructure.
And together, Steve and I have the pleasure of presenting some great results that we have on exceeding our customers' needs, on having the highest performance, the most energy efficient, and the lowest cost Nokia Core running in the networks. In particular, we're going to talk about our core running on Intel's latest Xeon 6 processors. But you will see as we move along that our results are such, the direction that we've embarked is such, that as the platforms and the software evolve, these results will continue to scale. And in fact, we'll continue to deliver even more aggressively. Steve.
So Intel and Nokia do everything possible to deliver value to their customers. Okay, so Intel has a long history of building great platforms to deploy in telco networks, and of course Nokia is a pioneer in the telco space, especially in the core. So we're able to bring these learnings together and innovate like never before. Now on the Intel side, we've been deploying Xeon platforms in the network for well over a decade. We've taken all of those learnings and for the first time with Xeon 6 to design a product around our E-core architecture. What that allows us to do is to scale up massively the number of cores on a CPU up to 288 per server, while also still continuing to have the most power efficient platform available on the market. Now on the software side, we're also investing heavily, and for telco, we have a very specific piece of software called Infrastructure Power Manager, and what this does is it dynamically matches the load on the system with the power being consumed on the system. So we're able to modulate frequencies up and down, and we can do it safely and we can do it intelligently. So we take these innovations, we provide them to Nokia, and they multiply that impact and that benefit, and Suresh is going to tell us how they do that now.
Steve, you spoke beautifully about the history that Intel has. Nokia has the same history. So when these E-cores were made available to us, we figured out how we're going to use all the cores through horizontal and vertical scaling by optimizing the mix of microservices that we have in the network functions and even enhancing some of the software functions so we can take full advantage of this. And Steve alluded to this earlier. What I really love about this collaboration is it is indicative of what good collaboration should be like, which is they generate new ideas which wouldn't have come about without the collaboration, plus the benefits that they gave compound, they multiply, as was mentioned earlier. And you see the example of that through the three categories that we shown on the screen. Now we're going to show you some results, and these results are our software running on the servers in the same way that would in the field, so that we get accurate estimates of the benefits and we are ready to deliver soon. So the most complicated function in the data/user plane is UPF. And what you see here is the performance of UPF on the right-hand side, the light blue bars compared to the dark blue bars. They show the performance of UPF on Sierra Forest, which is a Xeon 6 processor, compared to the fourth generation, which is the current processor, Intel. And for DPI traffic, which is the most compute demanding traffic, we get a 2.4x improvement in performance. And with the changes that we have planned, it will go up to 3.1x. For FWA traffic, you see a performance improvement of 4.6x and an energy efficiency improvement of 3x. These are large numbers, folks. These are very, very large numbers in terms of the savings that they imply. And on top of that, we will have 40% savings, runtime savings on power with IPM. Steve, why don't you tell them a little bit more about what IPM does?
Sure, of course. So this is a perfect example of running IPM in a network. So this was done in Nokia's labs with their CMG, which is otherwise known as UPF, right? This is real traffic in their labs, okay? So it's full DPI. And what we did was we ran a very indicative traffic profile that you would see at a COSP, right? So we ran it over a 24-hour period, and we measured the power consumed by those CPUs over that 24-hour period, okay? So we took a baseline without IPM, and then we reran the test with IPM. And what you can see is that over that 24-hour period, on the bottom here, we actually have a very large delta between the power consumed without IPM and the power consumed with IPM. It's over a 40% delta between those two configurations, right? And we're doing this safely and intelligently, as I mentioned before. So if there's packet drops, if there's any degradation service, it's not a viable product. We have none of that, right? So it actually is doing this without any impact performance whatsoever. We're very, very excited about this, and it's actually available in the 25.7 release from Nokia. So back to Suresh.
Thank you, Steve. Let's see. So another function is AMF in the control plane. Like we spoke earlier about a demanding function in the user plane, here's what happens in the control plane. So if you look at the two figures, you see a large deployment of 5 million subscribers on today's platforms. Today's best platforms, they would take up 10 servers. With Sierra Forest, you can do the same deployment on 4 servers. That's a 60% savings in footprint in number of servers. And your power is barely going up, which means your energy efficiency increases 2.5x. This is again a very, very large number. And as Steve showed earlier, we have the similar 40% runtime savings in power when you add IBM on top of that. So one thing that Steve did was, he just tried to give you a sense of what does it mean in terms of savings of dollars and emissions and so on. Steve, why don't you go through that?
Yeah, of course. Let me first show a demo of what we did for this server reduction. So this is an example. We took that CMM application, which Suresh was mentioning before, of 5 million subscribers. That footprint today fits on 2 third-generation Xeon servers. Okay, so two servers, 5 million subs. We can take that exact same footprint, and because of that increased core count, we can put that application on a single Xeon 6 server. Okay, so what you're actually seeing on the top graph in the middle is the exact same traffic flowing between both of those configurations, but because of the difference in servers and because we're using IPM, we now have a 60% difference in power consumed for the exact same capacity, the exact same application footprint, which is absolutely impressive. And something that should be noted, that you can do in any network today, going from 2nd gen to 3rd gen to 4th gen. Xeon 6 allows you to reduce that infrastructure dramatically. Suresh?
Yes. Thank you, Steve. So, Steve, this is great. Why don't you talk about the roadmaps some more, Steve? That's great. Please go ahead.
Sure, Suresh, thanks. So we have obviously a long history of Xeon products, back from starting from the 1st generation to the 2nd to the 3rd. The 2nd generation is actually extremely widely deployed in all networks today, but we continue to increase core count, increase density, increase performance throughout those generations, right? So you can see that we actually have a double core count kind of cadence moving forward for additional E-core platforms. So we're really, really excited about the density improvement, the performance to continue to increase, but the power efficiency, I can't say it enough, the power efficiency is just getting better and better with these platforms because of that move to E-core architecture. So we're really excited about deploying Xeon 6 today with Nokia and what the future holds with additional Xeon platforms with E-cores. Yeah. Suresh?
What's interesting to note here is that you see generation over generation savings, but when you multiply them, when you jump a few generations, there's a humongous improvement. You see that if you go from 2nd generation to 6th generation servers, you have an 83% reduction. That's unbelievable, absolutely unbelievable. Another fact is, we talked about E-cores. The beauty of E-cores is they're designed to be optimal for telco loads. So for the utility, the CPU utilization range that telco loads work in, they run 65% more efficient than any other cores on the same x86 architecture. These are just mind-boggling numbers. Now, of course, the next question is going to be, oh, this is all great. Your customers, when do we get it in our hands? So here's a roadmap. Our packet core, both CMM and CMG, are validated, and they'll be GAing on Sierra Forest or Xeon 6 for 25.7. That's in July, coming up. And then Sierra Forest is going to be adopted into our hardware blueprint in 25.12, and all the applications, the entire 5G core is going to get validated somewhere around the same time and a few months after on that hardware. Okay. Steve, tell us a little bit more about the server configurations that will be part of the blueprint.
Sure, Suresh. So today we have servers available from both Dell and HP in multiple configurations, but we found the best configurations for 5G core are either a 2-socket or single-socket configuration, which of course Nokia is going to use, but with the 144 core Sierra Forest product that I mentioned before. So we either have 288 cores on a server, or we have 144 cores on a server. Those are available today. They're orderable and shipping from HP and Dell. Want to wrap this up, Suresh?
Sure. So now, if you did not get anything else across, please remember this part. So this is a great collaboration, and I hope you saw the examples of what this has delivered. It has delivered the highest performing, most energy efficient, lowest cost core for your networks. Okay? And it came about because we went about it with purpose. Right? And in our collaboration, we ensured that we are listening to our customers. We are only working on things that matter to you. And we're trying to create new things, and we are aligning our roadmap so that we can deliver to that. The interworking is so close that we are testing our software in Intel labs before we even test it ourselves, so that bugs are found earlier and they're fixed early. This allows us to adopt platforms much quicker. Okay? And so I spoke about the multiplicative power of Intel and Nokia. But you can see that many of the innovations that Nokia has are going to work equally well on other platforms as well. So which means even if you, as the customer, choose another platform, these innovations will deliver. And that, I think, is the greatest strength of all of this. You will still have choice. Thank you.